You're standing next to a stone water trough on a small Amish farm in Holmes County, Ohio. No hose running to it. It has not rained in 6 days, and this trough is full. Clear water sitting quietly in the morning light like it has always been there. That water did not come from a well. It was pulled straight from the air overnight by a system that cost $12 to build. And some version of it has been working on this land for close to 200 years. But here is what the Amish understand about water that most of us never learned. The air is just one source, one of 11. 11 systems ranging from $0 to a few hundred that collect, store, move, and purify water without a single utility bill, without an electric pump, without asking anyone for permission. Most can be built in a single afternoon with materials from a hardware store. And the 11th one, the one that ties all the others together into a complete water-independent property, is something I have never seen fully explained anywhere. Chapter 1, Water from the Air. Right now, there are 12,900 cubic kilometers of fresh water floating in the atmosphere above your head, more than every river on Earth combined. Invisible, free, and completely ignored. The ultimate off-grid water source if you know how to collect it. The Amish did not ignore it. Condensation is simple. When warm, humid air touches a surface cooler than its dew point, water appears. You see it every morning on a cold glass, on the grass, on a spiderweb, strung between two fence posts with perfect drops that were not there the night before. That is a water collection system designed by physics, and you can build one for less than $15. System number 1, dew and fog mesh collector, $8 to $14. 6 by 6 F shade cloth mesh, about $5. PVC frame, $2. Gutter along the bottom edge, $3 to $4. Zip ties and bricks to hold it steady. Tilt 15 degrees into the prevailing wind. Elevate the base a foot off the ground. Set it up before sunset. Walk away. By dawn, water runs down the mesh into whatever container you placed below. Half a liter to a liter on an average night. 2 liters or more near the coast or in regular fog. Do not lay the mesh flat. Water pools and evaporates. Angle is everything. In 1987, researchers in Chile's Atacama Desert installed 48 square meter nets on a hillside, enough drinking water for 300 villagers from fog in one of the driest places on Earth. Nature solved this long before we tried. In the Namib Desert, the darkling beetle tilted body at 23 lasering into the morning fog. Its shell has bumps that attract water and grooves that repel it. Droplets form, grow, and slide straight into its mouth. MIT replicated that surface geometry and found it collects 3 to 5 times more water than standard mesh. System number 2, wool fleece collector, $0. In the 1600s, Francis Bacon documented North Atlantic sailors hanging raw wool fleece from ship rigging at night. By morning, it was heavy with fresh water. They wrung it out and drank it. Wool is hygroscopic, absorbs up to 30% of its weight in moisture without feeling wet. Lanolin, the natural oil, acts as a mild antimicrobial. The Amish raise sheep. Coarse fleeces with no market value sit in barns everywhere. Hang one at chest height, face the wind, ring at dawn. Half a liter to a liter per night, cost nothing. System number 3, radiative dew condenser, $8 to $12. Different mechanism from the mesh. Take a thin sheet of polyethylene or light metal, back it with polystyrene insulation, mount it at 30 diameter on a simple frame. At night, that surface radiates heat into the open sky. Temperature drops below the dew point of the surrounding air. Water condenses directly onto it. No wind needed, no fog needed, just a clear night. The key insight, thin and insulated beats massive and heavy. In the 1930s, an engineer named Knappen built a 14M stone tower in southern France to harvest dew. Spectacular failure. Too much thermal mass, never cooled enough at night. But in 1900, Russian engineer Friedrich Siebold found ancient stone mounds on a hilltop near Feodosia in Crimea, connected by clay pipes to the city wells below. He built a replica. Sea pebbles stacked into a cone, 20 millimeter wide, 6 millimeter tall. It produced 360 L of water per day. Atmospheric water, harvesting at scale was not theory, it was history. Today, a school in northwest India runs a 550 square meter installation on the same principle. 9,000 L per year. No electricity, no moving parts. System number 4, solar still, $5 to $8. The first 3 systems work at night. This one works during the day. Dig a pit about 16 in wide and 12 deep. Container at the center. Stretch clear plastic over the top and weight the middle with a small stone so it forms an inverted cone. Solar heat evaporates moisture from the soil. Vapor rises, hits the cooler plastic, condenses, and drips into your container. 100 to 150 milliliter per day per pit. 10 pits, 10 times the output. Bonus, a solar still can purify contaminated water. Pour dirty or salt water around the edges. The sun evaporates it, leaves the contaminants behind. What drips into your container is distilled. Now the honest part. Atmospheric water has real limits. These four systems need relative humidity above 30% and temperatures above 18 degrees C to work well. Fog collectors need saturated air plus wind. Solar stills produce supplemental amounts, not a primary supply. In dry climates with low humidity, these will give you very little. The air is never truly empty, but some air gives easier than others. Researchers are developing desiccant-based systems using cellulose gel and zeolite that pull water from air as dry as 10% humidity. Real promise for the future. But what you can build today in one afternoon for under $15 is what I just described. 4 systems, $0 to $12, water from air that was already there, just waiting to be collected. But atmospheric water has a ceiling. It depends on humidity, temperature, and patience. The Amish knew that, which is why they never relied on the air alone. They looked up. If these first 4 systems already changed how you think about water, yeah, hit subscribe. The next 7 get bigger. Chapter 2, water from the sky. A metal roof is not just a roof, it is a water catchment system. Here is the math. 1 in of rain falling on 1,000 SQ/ft of roof produces 620 gallons of water. A typical Amish farmhouse has roughly 2,000 SQ/ft of roof. Their region averages about 40 in of rain per year. That is nearly 50,000 gallons captured by a surface that was already there, doing nothing but keeping the rain out. The Amish prefer metal roofing pitched at about 45 degrees. Less than 2% of rainfall evaporates at that pitch, compared to 20% on asphalt shingles. They also run thin copper or zinc strips along the ridgeline. When rain washes over those metals, trace amounts, parts per million, flow down the roof and prevent algae from ever taking hold. No chemicals, no pressure washing. A metal roof lasts 60 to 70 years. Shingles last 20 to 30. System number 5, metal roof rainwater catchment. Cost depends on what you already have. If your home has a metal roof, you're halfway there. Add gutters, downspouts, and a collection tank. If you are building new, metal roofing costs more up front, but pays for itself in water alone. Here is something most videos on this topic skip entirely, the legal side. As of 2026, no state in America completely bans rainwater collection. Texas actively encourages it with tax incentives. Arizona does the same. Colorado, which was one of the most restrictive, loosened its laws in 2016 and now allows up to 110 gallons per household, roughly 2 barrels, for outdoor use. Utah permits 2,500 gallons without registration. States like Arkansas, Kansas, Oregon, and Washington require a permit but do not prohibit it. The trend over the past several years has been clear. Fewer restrictions, more incentives, but the rules vary by county. Check yours before you buy a single barrel. System number 6, rain barrel network with first flush diverter. The Amish use 4 to 6 interconnected barrels, often repurposed maple syrup barrels, which are food grade and already have bungs and fittings. The barrels are connected at the base so water levels equalize. The first flush diverter is the key piece most beginners miss. The first minute of any rainfall washes dust, pollen, bird droppings, and debris off the roof. A diverter sends that initial dirty water into a separate drain before clean water starts flowing into your barrels. Simple PVC standpipe with a ball valve, $10. Overflow from the barrel chain routes to garden trenches. A few drops of cedar oil in each barrel keeps mosquitoes out. Some Amish drop small fish, minnows, or mosquito fish into open barrels. The fish eat larvae. The larvae feed the fish, no chemicals needed. In dry climates, you choose between a wet system, pipes underground always filled, and a dry system, above ground, drains after each rain. Wet systems stay cleaner, but need drain valves flushed twice a year. System number 7, underground cistern. This is where storage gets serious, 1,500 to 2,000 gallons in a single chamber. Hand dug, 8 to 12 FT deep, up to 15 in some Amish communities, walls lined with local clay, which acts as a natural filter and sealant. The top is built as a dome, not flat, because a dome distributes the weight of anything above it, including a horse-drawn wagon. Some Amish cisterns built in the 1800s are still in use today. The bottom is bowl-shaped, so water collects at the center for easy pumping. Overflow channels route excess to gardens and livestock troughs. And the location is chosen by natural elevation. The cistern sits higher than the buildings it serves, so gravity moves the water without any pump at all. Now, how do you make any of this safe to drink? 3 stages. First, a sediment filter at 20 microns to catch particles. Second, a silver-impregnated carbon block. The silver prevents bacteria from growing inside the filter itself, while the carbon removes taste and odor. Third, a UV sterilizer to kill pathogens like E. coli and Cryptosporidium. Newer UV LED units draw almost no power and work instantly. Total cost for a complete off-grid filtration system, $150 to $400. Your rainwater comes out cleaner than most municipal tap water without a monthly bill. A note on sizing. A typical American family uses over 300 gallons a day. A 28,000-gallon tank covers about 7 months at that rate, but Amish families use an estimated 60 to 70 gallons per day. At that level, the same tank lasts over a year. How long your water lasts depends entirely on how much you use. 3 systems. Every rainstorm becomes a deposit into a bank that charges no fees and never closes. But rain is seasonal. The Amish plan for the months when the sky stops giving. That is when they reach down. Chapter 3. Water from the ground. The median well depth in America is 142 feet. In the east, Ohio, Pennsylvania, Indiana, most run 100 to 200 feet. Out west, that jumps to 300 or more. Amish country sits in the east. Their water is close. System number 8, hand pump deep well. 75 to 100 FT deep in most Amish communities, reaching aquifers that have been there for centuries. The pump is hand-powered, balanced so a child can operate it in an emergency, and an adult can pump.